Previously, we understood that after receiving an API call, the file system processes it through layers of different functions. Now, we will discuss how to implement their actual functionalities. Broadly, we will divide the implementation aspects into two types: structures on the hard disk and structures in memory. First, let's introduce the on-disk structure. This type of structure needs to permanently exist, so it is stored on the hard disk. The first type is the boot control block. We know that when the power is turned off, the data in RAM is deleted. So, which program executes when the computer starts? For this reason, a program is saved in a specific area of the disk. When the computer starts, the program is loaded from a dedicated space on the computer's hard disk. This dedicated space is called the boot control block. A boot control block, also known as the boot block in Unix, or the partition boot sector in Windows, contains information about how to boot the system from this disk. It is generally the first sector of the variant if there is a bootable system loaded on that variant, or the block will be left vacant otherwise. The second type is called the partition control block, or variant control block. We know that a disk can be divided into several partitions. A partition control block is needed to record which blocks belong to this partition, information about these blocks, and to track which blocks are free. This design allows the OS to know how to access this partition and these blocks. Notably, this partition control block is called a super block in the UFS system, and the master file table in NTFS system. After partitioning the hard disk, we usually format most of the partitions and provide them for directories and files to use. The directory structure can have various architectures, such as tree-structured, recording the related file names and file numbers under the directory. After processing the directory, the remaining space is used to store file and data blocks. Therefore, for handling file details, we use the file control block, FCB. As shown in the right figure, the FCB includes file permissions, creation time, modification time, access time, owner, group, access control list, file size, and information on which blocks the file is stored in. These are basic and common attributes of a file. When we begin to access a directory or file, we need to load some things into memory. so that the file system or operating system can process these related operations. The OS needs to know which partitions are mounted, and partition table helps the OS understand the relevant information about each mounted partition. Once mounting is completed, we need to access these files and data. Therefore, we also need to load the directory structure into memory to facilitate the OS and the file system in knowing the current directory's information. Please note that we don't need to load the directory structures from the entire computer into memory, as it would be a waste of memory space. We only need to load the directory structures of the recently accessed directories into memory. When we find the desired file through the directory, the next step is to load the system-wide open file table into memory. In this table, we stored the FCB file control blocks for each file we want to open. Do you remember what information the FCB contains? The FCB includes file permissions, creation time, modification time, access time, owner, group, ACL, file size, and information on which blocks the file is stored in. Since we may open many files at once, the FCBs corresponding to these files will be stored in the system-wide open file table for easy management and maintenance. Depending on the files opened by different processes or users, we can record process state through the per-proc open file table. This includes information related to the operations, such as whether it is opened for writing or reading, and which file handler is used. All this information is stored in the per-process open file table. To reiterate, this table is created based on the behaviors of process when operating on files.